All right. Shh. Okay, 6.1.
6.1.
Shh, no. I'm the only one talking, unless I ask a question so she can concentrate. Addition and subtraction. And Tanner, if you have questions, you can ask, okay? Yeah, see, those things don't work. Okay, shh. Joseph, we're respecting Tanner now. Okay, so adding and subtracting, yes. Okay, so for the rest of this week, we're doing 6.1 today, 6.2 tomorrow, 6.3 on Thursday, and then you have a quiz on Friday. This is a good stopping point before the holidays because this is kind of like a review. And then after the holidays, get some good stuff. This is going to be a great breaking point. So today we're just adding and subtracting. Yes. Okay, so we're going to be talking about adding and subtracting fractions. Oops. Adding and subtracting fractions. Raise your hand if you remember the main rule. Atalia? You need common denominators. That's right. See, I told y'all this is going to be. Shh. You add or subtract numerators only. That's when we're doing fractions. I don't know why I wrote that, because it only says fractions. So you need to have a common denominator. You add and subtract the numerators only. You don't add and subtract the denominators. No. You need to always rename improper fractions as mixed numbers. Always put fractions in lowest terms, meaning reduce, even if not in directions. Adding mixed numbers. Add integer, which is the whole number, and if those that forget what the whole number is the big number, and then add fractions. I'll let y'all catch up. Kelly, where are you at?
I'm on not even. Even if not.
Okay. I'll let y'all catch
My
up.
hand cramped up.
No, take your time.
mix up our thing.
Subtracting fractions. Whoops, mixed numbers. Subtract the fraction if the first fraction has a smaller numerator. You must borrow a whole from integer. And then 2, subtract whole numbers. Blah, blah, blah. I will give you examples in a little bit. I'm going to show you 2 ways of adding and subtracting, or mainly subtracting fractions, 2 different ways. But there's 2 ways of doing mixed numbers. There's this way, and then there is this way that a lot of people prefer. However, you can change the mixed number into an improper fraction and then add or subtract. You're dealing with bigger numbers, but the whole borrowing from a whole freaks people out sometimes. So when I was a kid, true story, subtracting fractions and borrowing a whole always messed me up. So I had a teacher that pushed this for me, and it actually worked out. I don't know. Some people don't like it because of all that work, bigger numbers and everything you have to deal with, but it really depends on you. And then this last part, well, that's a weird star. Adding and subtracting decimals. All those notes for adding and subtracting fractions, mixed numbers, improper fractions, etc. And for decimals, the only rule, always line up decimals. You're confused? Oh no, we're about to do it. So decimals, that's really the only rule. Lining up the decimals. That's it. That's it. Fractions have so many other rules. It's annoying. Okay, is everyone good? All right, open up your book to page 224. We're going to learn while we do a million examples. Not a million, because this is pretty much review. Tanner, you have a question? Okay, hold on. Let me pause. Come here. Then don't, if you have a question. Okay, 10. We're going to start with 10. Because okay, shh. Okay, so I really think you guys know how to do adding and subtracting of fractions. But we're going to do some examples just to remind you, okay? So yes, Atalia, you can do the first one. 1 over 12 plus 2 over 3. Okay, this is just basic. Okay, so we have to get a like denominator.
So we have to see which is the least common denominator. So 12 is the least common denominator, so it's still be 1 over 12. And then since you multiply 3 by 4, we multiply 2 by 4, which is
Okay, so she's correct. So since 3 goes into 12, how many times? 4. Then we have to multiply it by the numerator, because if we're going to change the denominator, we have to change the numerator. So 2 times 4 is, okay, now
9 over 12. And then you would reduce it
by,
3, 2, 0.
so we have a number that can go into both, and you get 3 over 4. Okay, very good. So this is not in lowest terms. So she said, since I'm recording this for Tanner later, 3 can go into 9 and 12. So 9 divided by 3 is 3. 12 divided by 3 is 4. Very good. Any questions? Joseph, does that help?
Yes.
Okay, let's look at 12. Yes, Kelly? Okay, so this time, and I'm going to show 2 different ways of doing this. So we have a whole number, 5.5, plus a whole number, 2 1/4. Now, one of the things I do suggest when dealing with whole numbers like this, well, first let me ask, Kelly, how are you going to solve this? Are you going to change it to improper fractions and then add, or are you going to add the way it is?
I'm going to change it to an improper fraction and then
Okay, so she's gonna go that other method. She's gonna change it to an improper fraction. So talk me through how to do that.
So 5 times 2 is 10, and then 10 times 1, and 10 plus 11 is 1.
You mean 10 plus 1 is 11, right? Okay.
Sorry.
No, you're fine. Over
2.
2. Plus, okay,
8.
4 times 2 is,
8. And then 8 plus 1 is 9.
very good, over
4.
Okay, so now we changed our mixed numbers into improper fractions. So we're going to add, but we have to have common what?
Denominator.
So what would be a common denominator for these? For 2 and 4.
So 2, 8. 8. Yeah.
Okay, 8, but could we also do 4?
Yes.
That would be a lot easier, right? But you could do 8. It wouldn't be wrong. So we're going to choose the easiest. So what is this numerator if we didn't change the denominator?
1, 9.
9, that's right.
Sorry, I was thinking
because we didn't change it, then the numerator stays the same. But since we changed this denominator, we got to change the numerator. How do I do that?
So you times it by 2, so
2 goes into 4 2 times.
and so it's 11 times 2, which is 22.
Very good. Since 2 goes into 4 2 times, 11 times 2 is 22. Now we can add across. What is 22 plus 9?
31.
Over 4. And we need to put that now back into a mixed number. 4 goes into 31 how many times?
29. I know it's in 9, but shoot. 7.
7 times. How much is left over?
3.
Over.
4.
Yeah. Uh-huh.
Can I solve it out? Doing it
The other way? Yeah, we're going to do the other way. Okay, are there any questions about doing it this way with the improper fractions? Okay. Joseph, do you understand this method? Okay, so let's look at 12 again. But see, that's what I'm saying. Everyone is different. So I have 5 1/2 plus 2 1/4. Now, with these, if you're going to do it the way Tanya does it, I tell kids that sometimes it's easier to rewrite it going vertical. Like this. Atalia, do you like rewriting it vertical?
No, I like this the way.
Okay.
That's just.
No, that's fine.
I'm looking for it.
And I'm going to run off to the side vertical so I can show everyone and Tanner in the video. You don't have to solve like this. So when I say vertical, I'm like this. This is what I'm talking about. And then some people like doing it this way. Like they change and they go up and down. Okay, it's entirely up to you. So you like keeping it this way?
Yeah.
Okay, so what are we doing here?
To keep the whole numbers. So
Okay.
it would still be 5, but then you have to get like denominators. So again, like the denominator is 4 on both sides. So this one's still 1/4. And then on this side, you multiply it by 2. Which would
Because 2 goes into 4. So 2 times 1 is,
2.
there you go.
And so then you just add across. So you would have 7.
So
And-
wait. Where did you get 7? Because remember, I'm recording this. Okay, so she's adding the whole numbers, 5 plus 2, which is 7. And then we're adding the numerators, which is,
3/4.
and we don't add the denominators, so it's 3/4. Perfect.
I find that one easy.
Okay, Tanner, you have a question? Okay, hold on, let me pause. Really, both, when I was a kid, for some reason, I liked doing improper fractions because the whole numbers gave me like trauma or something. So this didn't stress me out as much. Whole numbers, for some reason, just the way my brain worked, it stressed me out. So even though this is fewer steps, and you didn't have to like here, you had to go from mixed number to improper fraction and then to mixed number. That's a lot of work. But for some people, this, believe it or not, is less stressful than this. I mean, this is less work, you know? So some people are like, well, but there's way less moves here, you know? It's a personal preference.
Which one do you like better now?
I don't like fractions.
I can't believe you.
I just don't like fractions. Okay, let's do another. Hold on, I'll have Joseph do some work here. Okay, let's do some subtracting. Like,
Number 100.
I don't know why I just threw this example in here. Let's do an example of borrowing.
Oh.
I'm just gonna, it's not even a problem in your book. We're just gonna do a random example here. Okay, so Joseph, you're on board. 5 1/4 minus 2 3/8. Tell me how you want to do this. It can be vertical, it can be this way, it can be in proper fractions, it can be whatever you want it to be. Okay.
So, it goes with 5 times 4,
Uh-huh.
which is 20, plus 5, which would equal to 9. Can also
Shh. Okay.
And then you would do 2 times 8 and 5, which would be 16,
Uh-huh.
plus 3, which would be 19.
All right.
Least common multiple, which would be 8.
Okay, so we didn't change the denominator here, so do we have to change the numerator here?
Yeah.
But we did here. 4 goes into 8 how many times?
2,
21 times 2 is?
42.
All right, so now we subtract. Now we have to change it to a mixed number. 8 goes into 23. How many left over?
2 and 7.
All right. Any questions about that? Okay, but again, Ataya, everyone has their personal preference. Okay, and any questions about the improper fraction way? Ataya, I'm going to let you do it the other way, okay? All right. Let's do that same problem again. 5 1/4 minus 2 3/8. Okay, so tell me, do you want to write it this way? I mean, you don't have to write it up and down, but it kind of helps. It's up to you. Okay.
Okay. So leave the whole numbers and
Okay.
you have to have a like denominator. So they'd both be 8 because 8 is the like denominator. And so then you'd multiply 1 by 2 because 4 goes into 8 2 times. So it'd be 5 and 2 over 8 minus 2 and 3 over 8.
And this doesn't change because we didn't change the denominator. Okay.
So now you're gonna keep you're just gonna put the whole numbers. So you'd have 3. Wait, no. So okay.
You
I
can't.
didn't look at the 3. So you have to borrow a whole number from 5 because you don't have enough.
You can't do 2 minus 3.
Just get like negative.
So you can't do 2 minus 3, so we have to borrow from the 5.
So
Now I want to show, hold on, I want to show everyone. Kelly, you need to be watching. If I were to write it like this, I'm taking what Ataya has done already.
start at this.
Yes, you are writing this. Now, look how I wrote it vertically. So Kelly, can I do 2 minus 3?
Oh no.
Okay, so she said we have to borrow from the 5. We have to borrow a whole. So if I borrow from this 5, what does the 5 become?
4.
Okay, Ataya, 4. And then what do I add?
You add 8.
8 over 8. Because of the denominator of 8, a whole would be 8 over 8. So then that would become, Ataya,
Oh, sorry, 10 over 8.
10 over 8.
Or should I put it back into the other way?
And so I always just bring this over. So then subtract. Go ahead, you tell me.
So 4 minus 2 is 2. And then 10 minus 3 is 7 over 8.
There you go. Do y'all understand that method? If you subtract and you have to borrow, you take away from one whole from the whole number, and you add a whole based on the denominator so that you can then subtract. Any questions? No? Okay. Let's see, I'm going to do a couple of decimals. Let's see here.
Really with decimals, it's just subtracting that. Just keeping the decimal right. Just keep the decimal. Going straight down. Really?
Everyone's different. Okay.
Decimals are easy.
But that's you. Let's look at 24. So is this kind of like a refresher course for y'all? Do y'all remember how to do all this stuff?
Yeah.
Do you, Joseph? Joseph?
Yeah, I still remember.
Okay.
I remember it all. It's just different from this.
Are we good on the fractions? Okay.
Just messing up with that other legs. Just, I don't know.
What if, real quickly, what if we did a bunch of work and let's pretend the answer was 2 and 9/8? Who can tell me what to do?
In what sense?
That's your answer. But that's an improper fraction. So what do? Joseph, are you paying attention? What if the answer was this? Italia, what do we do?
So you would kind of just put the 2 off to the side in a way. So how many times did 8 go into 9? 1 time. So you'd add the 1 to the 2.
Okay, so listen to what she just said. This is an improper fraction. We have to change it to a mixed number. 8 goes into 9. How many times, Italia? So we're going to add that 1 to this 2. It becomes 3.
And then
What's left over?
1 over 8.
There you go.
Rewrite that.
That's only if you didn't know how to do that. Okay? So if your answer is like this, a mixed number and an improper fraction like this, you have to change it still to a mixed number by saying 8 goes into 9. How many times? 1 time. Well, that would be your whole number 1. You would add that to the 2, and you get 3 over. Yes.
So if it were to give us an improper fraction, a mixed number that's improper, that makes sense. Like that.
Like this.
And we would have to put it into an improper an improper fraction. Would we have to make it 3 1 over 8 4? Or does it
No. It doesn't matter. You just go ahead and change
you
it.
get the same answer.
Yeah. Okay. So let's look at 24. It's negative 7.13 minus negative 4.7. Who remembers when we have a negative in front of a negative? Italia?
Positive.
Changes to a positive. Okay, do y'all see that? When you have a negative in front of a negative, it becomes a positive. Okay, Italia, tell me how to set it up.
So you put negative, and you want to line up your decimals.
Yep, you want to line up your decimals.
So 7.13. Write it, negative 7.13. And then plus, plus 4.7. And then add a 0.
There you go. See, Joseph and
Yes.
Kelly, do y'all see that there's a space? Okay. Now, here's the thing. Your larger number always needs to go on top. Okay? Now, if it's a negative and a positive, what are we doing here?
You subtract and
We're-
keep the sign of the large number.
We're subtracting and keeping the sign of the large number, so your answer is definitely going to be negative. So then, Italia, 3 minus 0 is? 1, you have to borrow.
6, which leaves you with 11.
11 minus,
7 is 4. And then 6 minus
bring
4.
down your decimal.
Yeah. And then 6 minus 4 is 2.
Okay. Any questions?
I don't understand how that's 4.
How-
What's it turning into an 11 or
It's just subtracting.
Okay, so we're subtracting because this is a negative number and that's a positive. When the signs are,
the 1 of the 13?
Because you can't subtract 7 from
Does it turn into an 11 or a 10?
listen, it's 1, right? Can we do 1 minus 7? So we borrowed from the 7, added the 1 here, so now it's 11.
It's just like normal subtraction.
So, like, if we were to add a 1 to this 3, it'd be 13. If we were to borrow from there, if we were borrowing that and we added a 1 here, that'd be 13. So that, if we're borrowing, that becomes 11.
Sorry, I got confused.
That's okay.
I knew we were borrowing 1 for 7.
You just forgot it's not 10.
Yeah.
Okay.
So I thought I was like, is it 3?
All right, let's look at 22. Okay, I'm gonna let's see, Kelly or Joseph, who wants to do this one? Kelly, all right. Okay, my suggestion, always put what number on top, Kelly?
The higher one.
Okay, so then what's going on top?
So it's negative 9.97.
Okay. And then underneath is negative 5.28. And we line up our decimals, which is easy to do because they're both same digits and in the same place. Now, Kelly, if they're both negative, do I add or subtract? If their signs are the same, we add and keep the sign. So the answer is going to be negative since we are adding. So, Kelly, what's 7 plus 8?
15, but you move the 1 over 9.
And then
9 plus 2 is 11, but you also add the 1, so it's 12. Then you move the 1 over the 9. 9 plus 15, and 9 plus 5 is 14, and the 1.
so you get 15. And don't forget your negative sign. And don't forget to bring down your decimal. Any questions? All right, you are doing page 224. Numbers. We did a lot of evens, didn't we? Yes. Yes, we did. So then you're doing odds. You know how to do there you go, 9 through 27 odd. That's like 10 problems. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Do, oh, that's do Wednesday. You have a quiz Friday. Okay. All right, y'all can get started.
What?